Hello everybody. Today we're going to learn about the percent composition of known substances. And we got 4 substances today that we're going to work with. The purpose of percent composition is to figure out what percent of the mass of a whole substance is due to the mass of some individual element within it. So for every problem, we're going to first try to figure out what the original molecule weighs. And to do that, we're going to go to the periodic table, look under the symbol, and you're going to see a number. So for carbon dioxide, we look at our periodic table and we see that C weighs 12, and there's only one of them. Oxygen weighs 16, and there are 2. So the total is 44 grams. And for those of you who know, that grams tells us that we're talking about a mole of CO2. A mole of CO2 weighs 44 grams. Now, what percent of that 44 grams is due just to the carbon? In order to do that, we're going to first take how much carbon we had and divide it by the total. And we're going to times by 100 at the end to make it a percent. When you do this, you get 27.3%. We're going to repeat this procedure for oxygen, but you don't really have to because there's only 2 elements here. And you know that all percents add up to 100. But let's do it anyway. And we get 72.3. Sorry, 72.7. And that's it. We're done with CO2. CO2 is 27.3% C and 72.7% O. Now let's try KCl. For KCl, we start exactly the same way. Potassium is 39, and chlorine is 35.5. And that whole thing adds up to 74.5 grams per mole. Let's see about K. When you do this out, you get 52.3% potassium. And like I said before with carbon dioxide, there's only 2 elements here. So you can do the math, or you can just know that all percents add to 100, and you can figure out the rest. And there you go. Let's do 2 more. Some molecules have parentheses in them, and what that parentheses tells you is that the things that are inside of it have been multiplied by this number outside of it. So for MgOH2, there is 1 Mg, which weighs 24. There are 2 oxygens, which each weigh 16. And there are 2 hydrogens, which each weigh 1, for a total of 58. And once we have the total, we're going to continue to repeat the steps that we had before. And we get 41.4%. Now, this substance has 3 elements in it, so we do have to figure out at least one more before we can add up to 100. Let's do oxygen. And this is 55.1%. And using some addition, we realize that all percents have to add to 100, and so that percent hydrogen must just be 3.5. Okay, for the last one here, you've seen a few examples. So I'm going to write down some information you're probably going to need here. First thing to recognize in this is that there are 4 n's, and each n weighs 14. And there are 12 h's, and each one weighs 1, for a total of 68. Okay? Now I'm going to let you try to figure out these on your own. Pause the video, and when you feel like you've got a successful calculation, unpause it for the answer. Hopefully you got that right, and hopefully this helps you with percent composition of known substances. Thank you. See you next time.